So yeah, hi. And hi everyone. Thank you for attending this workshop. It's a Saturday afternoon. So it takes real, interest to actually show up. So we are really happy about it. Um, I joined a little bit late, so I'm not sure if we have already spoken about the Slack channel that's there and the documentation that you can refer to. Did we already share that information?
We've shared the information about the Slack channel, not
Okay.
about the documentation.
Okay.
All right, so I'll just put that in the chat.
Can you also post that on the Slack channel version?
Yeah.
So we'll begin with how we are going to conduct this workshop. This is a pretty long workshop, so we have planned breaks in between. And it is going to be a mix of some theory, but also, hands-on exercises. We don't want to, do just basic hello world examples, but we really want you to take away real world use cases from this workshop and hopefully apply to your organizations. So this is the documentation that you can refer to. So this workshop is hosted by Nirmata, and this is going to be a basic introduction. We'll do deep dive as and when necessary, but it's not going to be complete internals of Kyverno. For that, we'll provide information at the end of how you can get involved or how you can start learning more about Kyverno. So there are like 7 modules planned. We will try to keep it at a pace that is comfortable to everyone. So in case if you feel that we are going a little bit faster or slower, just let us know in the chat. We want to understand where everybody's Kyverno knowledge level is at so that we can level set the field and take it from there. So feel free to know in the chat if we are like over repeating something that you already know, or if you want us to talk more about a particular topic. So with that information, I will start with the presentation. And also, feel free to ask questions on Slack or on Zoom. And so when I'm presenting, Arjun is going to be answering, or and vice versa. Otherwise, feel free to answer your peers. If some of you may already be well versed with Kyverno, or you might know the basics of Kyverno. So feel free to help each other out. This is going to be a collaborative exercise. So I hope you all are like, with a cup of coffee or tea or whatever, but we'll definitely take coffee breaks. All right. So these are some of the prerequisites. So this is also mentioned in the module 1. So I don't think so. Okay, sorry. So you'd be needing kubectl. We will run this locally on a kind cluster, basics, Git, Helm. If you want to like edit policies, you can use, Vim, Nano Editor, or even Visual Studio Code is recommended. So I hope all of us here have already, up with this setup. Okay, next. So what are we going to do in today's workshop? So we will start with, what is policy, why policies matter. And along with this, we learn a little bit, a better understanding of Kubernetes in terms of how webhooks work and, what are admission controls and so on. And with that, we will, get a nice segue into what is Kyverno, we'll go through the high level architecture, what a particular Kyverno policy looks like, and then start with the use cases from there. So you as a participant, depending on what you do in your organization and what your policy journey is going to look like, you can take away several things from here. If you're like a complete beginner, hopefully this session will be useful in understanding why policy is necessary to you and to your organization. So you can be that person who can influence in your organization to, set up policies, to secure guardrails, and, to make your Kubernetes environment more secure. And you can also, get started with Kyverno. So if some of you may have worked with OPA Gatekeeper before, and Kyverno is something new to you. So you might try to draw some parallels and also, identify what is the difference between these two policy engines. And then we will look at some real life policy use cases, how you can use this in your day-to-day DevOps jobs, or, in your just normal regular workflows and pipelines. You can introduce Kyverno. And like I said, we are not going to do any hello world examples. So these are all real world use cases, but you may be surprised that they are as easy as a hello world example. So that's the beauty of Kyverno. And what are we not going to cover? So we are not going to cover, the inner workings of Kyverno. We are not going to go in depth. And there are some advanced topics, and I think this workshop is going to be based on Kyverno 1.9. Kyverno 1.10 beta was just released last week or earlier this week, I guess. So we are not going to be covering any of the beta features, but we are going to cover everything, almost everything up until 1.9. I realized I should do the slideshow mode. Okay. So this is us. So feel free to reach us out on Slack or on these handles. I already mentioned about this, so we're going to cover a lot of things today, but we are going to take ample breaks in between so that we are not overworked. All right. I think with this, I'll hand it over to Arjun. Arjun, do you want to share screen or do you want me to continue?
Yeah, let me share my screen.
Okay.
Hope it's visible.
Yes.
Yes.
So let's start with the introduction and why we are all here. Let's talk about Kyverno, a bit about policies and all that context. So why do we need policies in the first place? Anywhere we go, any organization or any system that we deploy, why do we need policies there? So it's usually simple when you have one person working on everything, but when you are collaborating with multiple people, things get complex. Even as a single person deploying something, you have so many things to manage, things can get complicated. And that way, bad things can happen. So there can be security breaches that you might not have thought of, or accidentally maybe you push something, you bring down your production, something happens, right? And people make mistakes. It could be you, it could be your intern, it could be anyone, and there can be major consequences of such mistakes. So Kubernetes itself is designed to be simple. We do everything in YAMLs, but even so, as the scale grows of your cluster, of your deployment, things get complicated. So that's where policies can help us. They reduce risk, set our expectations of others, which means that you can basically talk about what someone can do and what they cannot do. And then it ensures that you have consistency, you have security, you have rules in your cluster. And it therefore saves us time. We avoid mistakes which can cost us resources, time, and just save us from headaches, right? So policies in general, I talked about what they do for us. So they can be a set of rules, ideally, which dictate how a cluster or a system behaves. And they act as guardrails for us. Also, they ensure consistency and therefore governance, help us with governance. And then when we talk about the third point here, observability, Kyverno has this feature where it can generate policy reports. So these reports are about which resources are violating which policies, all that you can see in a collated view. And of course, you can do other tasks as well, such as automation. So in Kyverno, we'll talk about different types of rules that we have. And these rules one of these rules is the generation rule that can help us with automation. We'll see examples and we'll talk about that later. So basically, policies in general would help us dictating how the cluster functions, who has access to what, and how our resources are defined, thereby improving security, ensuring that we are compliant to some standard, including your internal as well as organizational compliances, right? So, and we also eliminate problems such as pod security or misconfiguration or network compliance. All those things also we take care of through policies. And we will take a look at later what are the use cases where Kyverno can help us with. And there are a lot of them, just to list, right? So let's dive into, okay, before that, let's look at this picture, right? So with on the left, you have a very organized system, right? On the next year, you have wreaked havoc. And this is basically what you have when you don't have guardrails, when you have a very large system but you don't have policies, let's say, right? And why are we talking about Kyverno today? Maybe why is this workshop not about something else? So one of that is because Kyverno is designed to be very simple. It's designed to be Kubernetes native. And right now, this is you can see this is the communities trend. We are seeing a lot of traction on Kyverno simply because of this reason. You don't need another programming language. It's all written in YAMLs, and the policies are as easy to write as they are to read. So, and they recently we have reached the incubation phase. So CNCF, we are CNCF backed, and we are in the incubation phase now. And the best part about Kyverno is it has a lot of examples. So even the ones where that will show you, most of them are from the Kyverno IO docs. They have around over 200 policy examples by now. And other cool features of Kyverno, such as it's obviously highly extendable, and you can run it inside your CI/CD pipeline as an admission webhook inside your cluster, or just as a CLI as well. So those features are what make Kyverno compact, very well versed with Kubernetes natives, and just make it simpler to use. So how are policies implemented, and how do we handle them in Kubernetes? How do policies work inside Kubernetes? So Kubernetes has this construct of admission controllers. So admission controllers, basically what they do is that whenever you admit something to your cluster, or whenever you change something in your cluster, the admission controllers get a notification. We call them admission review objects. And these review objects have the definition of that change or the resource that has been changed, and as well as the delta you can see there, right? So these things, if let's say you know what has changed in your cluster, you can check what policies it's violating or what policies need to be applied. And of course, this happens after you have gone through authorization and authentication. So that means that these admission controllers don't work outside of your cluster. Only when the resource is very close to the cluster and want to be inserted into your etcd, then admission controllers come into the picture. And there are two types of admission controllers. One is the integrated one, which is what Kubernetes supports out of the box. There can be such as pod security, PSA. Now we have, earlier we used to have PSP as well. So resource quota, limit ranger, all these are examples of integrated admission controllers. And then we have external admission controllers, which are defined through two Kubernetes resources, which are mutating admission webhook and validating admission webhook. So basically, these are just definitions of those admission controllers. You just define that these resources that are coming in, they should go to these admission controllers. So policies, when we are implementing in Kyverno, we implement them as YAML files. And then these YAML files are what the admission controller looks at to verify whether the policy is, or whether the resource is as expected, or if we want to make changes, generate new resources based on that, we do that. So, again, it just follows the controller paradigm. So if you're familiar with controllers in Kubernetes, they are essentially, they can watch resources, they can monitor resources, they can look for changes in the resources and help with their admission. So basically, the idea is to monitor something for changes, and based on that, the controllers take action. So, okay, we talked about what the controller is. So as I mentioned earlier, we have admission review objects that go to the controller. And these are, of course, not triggered by reads, because you're not changing essentially anything in the cluster if you read something, right? So these are triggered by 3 or 4 more like operations: create, delete, modify, or this one, connect, right? So these operations, you can choose which operations function for which controller by defining your mutating webhook or validating webhook. And let's take a look at that. Before that, let's look at, so we were talking about admission controllers and external admission controllers. So external admission controllers are also, so they are basically just dynamic admission control. This is the mechanism they use behind the scenes. And you can see in the diagram here, whenever we have an API request, admission, modification, something like that, so it would go to the API server, then the API server would do authentication and authorization, and then it would come to this mutating admission. So mutating admission is the part of the admission controller, which looks, sorry, not part of the admission controller, but part of the Kubernetes admission, which would check for admission controllers that are in the mutating configuration. That is, whenever we have, so let's understand maybe what's mutating firstly. So whenever you have a resource coming in, let's say I want to, I am admitting a deployment. So, and I want to by default add a label to that deployment. Then this means that we want to, whenever the deployment comes in, we want to mutate that resource and add that label. And these configurations, these controllers can be registered to the Kubernetes Kubernetes API by using the admission mutating admission webhook. So these are what you see here. The webhooks get those requests, do the modification, send it back, and then you have validation. So after mutation, you have schema validation. Kubernetes checks if the schema is as expected. And then it comes to validation admission. So validation, as the name suggests, it just checks if the resource is as expected. Now these, earlier we have this object schema validation. That just checks how the CRD or the resource schema is. But then you can have rules on that. This is where policies are. So where your validation rules are, those rules are being checked here. And after that, the resources are sent to etcd for storage. So as I said earlier, we have two types of webhooks, mutation and validation. And then basically you can let's maybe run this. All right. So you can see the explanation for these. I'll do for mutating webhook. Okay. So you have these fields, the standard API version, kind metadata, and then you define webhooks. So I'll show you an example later for these two. And then ideally what they do is what resources should they define, what resources should be sent, where they should be sent, and how the communication should be treated. As in, like, you set the time to live for that communication or something like that. Right. So this is your example webhook. Here we have a validating webhook, and these are the essential fields that we have highlighted here. So you define which where the requests need to go to, and so you have a service here, and then the failure policy. That is, whenever the admission request is not able to process it, what do we do, right? Or more like if it says that the validation has failed, what do we do, right? So, and then you have the time to live for that connection, and then the rules. So rules are basically you define what operations and what resources for those operations would go to that admission controller, right? So by the way, if any doubts you guys have, you can stop me in between or ask Anusha. So, and then we were talking about the object that goes in to the admission controller. That's called the admission review object. So let's say I have this resource, right? And this resource, whenever I admit to the Kubernetes API, if I have the admission webhook defined, then it would mutate this, or rather create this admission review object, which would have all this information, which can help the controller in doing whatever operation it's supposed to do. And operations, as we talked about, there are 4 operations that are supported. So in summary, whenever we have in production deployment, ideally, at least in production deployment, we must have policies so that we ensure that the cluster is secure and compliant, and later on we don't have headaches, or we don't have to manually do resource management. And then we have custom policies which we can implement with admission controller. We have the native policies that you can do with Kubernetes, such as the ones with policy security, pod security admission. We'll talk about them later as well. But then you need something granular when you're talking about policies in large clusters. So usually that's where Kyverno or OPA Gatekeeper or other policy engines come in. And webhooks are basically the bridge mechanism. That is to say, they define which requests go to which admission controllers, where those controllers are defined, and so forth. And then ultimately, when we are talking about Kyverno, it's pretty simple to use, lightweight, and works out of the box when so it's like you can deploy Kyverno with one command right now, and we'll see that as well. And everything, whatever admission requests come in, they get sent to Kyverno as an admission review object, right? And then now I'll hand over to Anusha for the installation and policy overview. Anusha, do you want to share the slides?
Yes, thank you. Yeah, okay. I don't see any questions so far, so I'm going to move ahead. So that was a really good overview. Thanks, Arjun. So now we will start, we'll start with installing Kyverno, and then we'll look at what a policy looks like, and we'll examine various fields. All right. How did I end up here? Okay. Okay, so Kyverno runs intra-cluster. So it runs within your cluster. So you'll have to have a Kyverno deployment for each of your clusters. And you can run it in high availability mode, especially if you're running a prod cluster. We recommend you to run an HA mode. So that means 3 replicas of Kyverno. And Kyverno is easily installable as a Helm chart. So here is the Helm install command to install Kyverno. And there's also a raw YAML available. So if you look at the release artifacts that are there, you'll be able to get the raw YAML for it as well. But as mentioned here, it's mostly for testing. Otherwise, we prefer using Helm way to install. This is the high-level architecture. So if you observe here, the top gray part of it is the exact same what Arjun was showing just a while ago. So this is how API request is handled in Kubernetes. You start with authentication and authorization, and only if you have registered any webhook, your request get redirected to the webhook. So first it goes to the mutating admission control. It does any mutation if there needs to be done. Once you mutate the fields, obviously your schema has to be validated. So that's where it goes through schema validation. And then it goes to the validating admission control as a last stop. So at this point, if the validating admission control says, no, this is a bad request, your request can be dropped. But if the validating admission controller says this is a good request, go ahead, only then it gets persisted into etcd. So this in this entire API request path, Kyverno acts as an admission controller. So it acts as both mutating admission controller and validating admission controller. So if you see this full box, it is a bunch of controllers and an engine. So this engine is the heart of Kyverno. So this does all the rule processing, and all the various controllers, these are Kubernetes-native controllers, they react to different kinds of events. So there are different custom resources. So like we always say, Kyverno is Kubernetes-native. So what does that actually mean? So we follow all the Kubernetes patterns of controllers and, extended via custom resources. So these are all the different custom resources that are there. There's admission reports, there's policy reports, there's scan reports, and policy exceptions is a new thing that we have introduced in 1.9. And we are also going to do a hands-on of policy exceptions today. And policies, these are, this is like the bread and butter of Kyverno. So there are different types of cluster policies and policies available. This is a high-level architecture, and this architecture is evolving. That is, this Kyverno part of it is continuously evolving with every release. With every release, we are making sure that it becomes more modular and more robust. Like Arjun mentioned, we are in the incubating phase. So we do have like rapid changes that occur in every release, but the end goal is to reach a more stable kind of an architecture. So moving on, the policies as CRDs. So there are 2 types. So there's a policy and a cluster policy. So think of it something similar to roles, like we have role and cluster role, right? So role is always namespace scoped, and cluster role is applicable throughout the cluster. Similarly, cluster policy is cluster scoped. It is applicable throughout your cluster, and policy is namespace scoped. So you'll have to specify this policy is applicable in which namespace. It is Open API v3 compliant. It is fully described. So you can use kubectl explain to explain any of these CRDs. And you can use Kubernetes RBAC to control different policies and cluster policies. You can write RBAC in terms of say you're a platform team or a DevOps team, you do not want your developers coming and changing in policies. So you can write finer RBAC controls for this. Policies act as webhooks, and there's a failure policy. This is quite important. So failure policy means, and because we saw that Kyverno sits in the critical path of your admission control, it is very important that Kyverno should be up and running all the time. But what happens if an attacker, attacks the Kyverno deployment itself and brings it down? Now, this means your API server cannot reach Kyverno. So does it mean none of the requests now go to the cluster? It might very well go, right? It means your cluster is now down. So how can you prevent this? So there's a field called failure policy. So you can set it to fail or ignore. So fail means if for any reason your Kyverno becomes unreachable or it goes down, all the API requests would be dropped. And you can also set it in an ignore mode that says, okay, my webhook is not reachable, but you still go ahead and persist my request. Now, there are different pros and cons to this. Maybe in something like a dev environment, you would not want, if Kyverno goes down, you would not want your request to stop. But in case of a production environment, which is a very critical environment, even if Kyverno goes down for whatever amount of time that may be, you do not want bad requests, persisting in your cluster. So it is always advisable to set failure policy to fail in a production environment or in any critical environment. But in lower environments, you can, relax a little bit and set it to an ignore mode. But the general recommendation is to set it in a failure mode. And also, like in production, you have to always set it in HA and failure policy to fail. You can also set webhook timeout seconds. So this is nothing but a service that is registered, right? So it might be possible that your webhook doesn't respond in the given time interval. So do you have to wait forever? No. So you can always set the timeout seconds. Again, these fields are not very particular to Kyverno itself. So this is any generic webhook recommendation. Moving on. Okay. So in Kyverno, we talk about policies, but this is a typical policy anatomy. A single policy can have one or more rules, and each rule will have majorly this match exclude block. So it means you can match on all these different, resource kinds, names. You can match on incoming request labels, annotations, and a whole bunch of things. Similarly, you can say exclude on certain set of kinds, names, and resources. So once you match and exclude certain resources, you finally write different rules in your policy. So there are different rule types. So there's validate, mutate, generate, and verify images. Validate is simply saying it's kind of like a Boolean. We say yes or no, whether this rule passed or failed. So if it passes, it'll allow your request. If it fails, it won't. Mutate is you actually mutate the incoming request. Think of something like you are a security admin or a platform admin, and a general best practice is that you don't run containers with latest tag. So you always want your containers to have either an image tag is specified or an image tag specified. So now what you can do is if you can look at the incoming request, you can look at the pod spec, you can get the container reference. And if a latest tag is being used, you can mutate that to use any tag that you want or change it into image digest. And then you can also generate resources on the fly. So think of it, we will actually go through the generate exercise today. So think of something like you're creating a new namespace, but once you create a new namespace, you would want, to create network policies, limit range, quotas, and so on. So just by looking at an incoming new namespace request, Kyverno can generate all of these resources on the fly for you. And then finally, we have verify images. So some of you must be aware of, Sigstore's cosign feature, wherein you can sign container images, you can sign YAML manifests, and Kyverno integrates with cosign, and most recently with Docker's Notary V2 as well. So if you sign your container images using cosign or Notary V2, at the time of deployment, it is possible to verify that these images were actually signed by, the private key, or the person holding the private key and who they claim to be. So it is very easy to write such kind of policies as well. We will also go through this exercise today. So in general, this is a basic policy anatomy. So you have policy, and a single policy can have multiple rules, and each rule can have different types. So this is a sample policy. So again, like Arjun mentioned, there's no programming language involved. All of these are just plain old YAML files. So you have API version, you have kind, this is a cluster policy. So this policy is applicable throughout the cluster. You can add any amount of metadata or annotations. And then you have the spec field. So here, this field is quite important, validation failure action. So we have two fields here, enforce and audit. So enforce means when we saw in the API request path, the final control was the validating admission control. So when you say validation failure action as enforce, so if your validation admission control returns false, that is, you are failing some validation rules, then your request is going to get dropped. But what if, again, you're in a lower environment and you don't really want the request to be dropped, but you want to know if, if there are bad requests coming in, then you can set this field to an audit mode, wherein even though the rule fails, it is going to allow your admission request, but then generate a report for it and, also warn you that a bad request, has entered your cluster. So generally in production, it's good to have enforce, but it's also possible to set this in audit mode. And then we have the background field. So what about, you already have an up and running cluster, there are applications running, and now you learned about Kyverno today and you want to introduce Kyverno, or you want to try out Kyverno in some of your environments. So there are already resources present and you want to know which of them are actually bad requests. So that is where you set the background to true. So what Kyverno does is once you apply this policy, it is going to perform a background scan. So it will check out of all the existing resources, which resource fails, which policy and rule. It is going to generate a nice policy report for you. And then coming to the rules. So this is a validate rule. So we said there are 4 types. So this one is a validate one. So before that, rules is an array because we said a single policy can have 1 or more rules. So this policy is matching on resource kind pod. So this means for any incoming request, if it is a pod, the API server is going to reroute that request to this particular, webhook or policy for rule processing. So this happens on all pods, and we validate certain things. So what are we validating here? We're saying the label team is required. So it means for any incoming pod, there should be a label called team in this particular resource. We're saying pattern metadata labels team. Here we are saying question mark star. So this is a simple regex to say there should be some value present. The key team has to be there, but the value can be anything. Basically, there should be some value. Now, this is a very simple regex, but Kyverno supports really complex regex patterns. So if at all there is a need for you to use that, the policy library or even the documentation is quite extensive on the different kinds of regex that are supported. So this was just a validate policy. If you were to look at mutate, and in the exercise today, we'll look at generate and verify images. Everything else up until this point is going to remain the same. So what's going to differ is the rule type, and based on the rule type, the rest of the structure will follow. So this is like more policy behavior. So this serves as logical container for rules. So the whole idea is to write different rules that are relevant for your use case, and policy serves as that container to contain all the rules. So you club all the related rules together into a single policy. Some fields control behavior, such as validation failure action, background and failure policy. So we went through in depth on all of these. And rules are applied in policy definition order. So it means if there are multiple rules over here, so this is going to get applied in this order that you specify in the policy. Okay. So one rule cannot override another. So all mutation rules apply first regardless. And why is this? Okay, suppose say there was validate here and you have another rule type called mutate. So even though you have validate written first, the mutate is going to apply first because as we saw in this diagram, mutating admission control always happens first and only then validation. Because suppose say if you do validation first and then you end up mutating, but what if the mutated resource does not conform to the validation criteria? That is why this is not a Kyverno behavior, it is Kubernetes behavior in general. Mutating admission always happens before validating admission. Yeah, it is common to organize rules into policies if they are related. So it need not be that you need to have a single policy YAML containing hundreds of rules. So it is always good to break down these rules into different policies of, there should be some commonality between the rules. Selecting resources. So you can use the match exclude block. So matching is highly flexible. As we saw, we can match on a whole bunch of things, kinds, namespaces, labels, and so on. So you can do things like match any of A, B, or C, or match all of A, B, C, and so on. And similarly, you can do exclude. And the cool part is you can also include wildcard in this. So you can say match all namespaces starting with test or match all namespaces starting with prod. So things like this becomes really easy when you're writing a policy. All right. Are there any questions up until this point, or we can get started with the lab? So for the lab, we are going to follow this tutorial. So in this lab, you'll build the necessary environment that is needed for the remainder of this workshop. So we'll need a Kubernetes cluster. In this tutorial, we are using kind. So feel free to use Minikube, K3D, or whatever that you're comfortable with. We will then install Kyverno, and then we'll inspect some of this Kyverno CRDs. So I'm going to execute some of this with you. Let me pull. Yeah. So first, we're going to create the kind cluster. Once we do that, we are going to add an repo and then update it. So I hope you are executing along with me, or you can feel free to, just watch as I do some of these exercises, because this is available as a Git repo throughout. So you can also refer to these exercises at your own pace later on. And the Slack channel that we created is going to be active for maybe 2-3 more days. So if you have still any further questions, you can post them on Slack. So I added the Helm repo. I already have those repos, and okay, now I'm updating it. Now we'll install Kyverno. So this is how easy it is to install Kyverno. So we are installing this from the Kyverno chart, and we are creating a new namespace called Kyverno. Let's look at if the pods are there. So yeah, you can see 2 pods for Kyverno that are there. Okay, let's wait until this is up.
In the meantime, if any of you is working, the labs along with Anusha, and if you have any questions, you can unmute yourself and ask it. Yeah. All right. Carry on, Anusha.
Yeah. Thank you. So we see that both our Kyverno pods are up and running. Now we'll look at some of the CRDs. So, like I said, Kyverno is Kubernetes-native, and we extensively use custom resources to extend Kubernetes functionality and behavior. We have admission reports. We have background scan reports for all the background scans that happen. Cleanup policies is something, again, new in 1.9 with Arjun is going to cover. We have cluster admission report. We have cluster background scan. Cleanup policies is again something Arjun is going to cover. Generate requests, policies, policy exceptions, and so on. So all of these custom resources help extend Kyverno and make it feature rich. We will look at a cluster policy. So like I said, you can use kexplain. You can use all the kubectl fields that you're familiar with, kubectl commands that you're familiar with Kyverno, because everything in Kyverno is custom resources and controllers. So this is a cluster policy. The kindest cluster policy version is Kyverno v1. So there are different fields: API version, kind, metadata, spec, and status. So any custom resource is typically formed based on these fields. You have GVK, that is group version kind, and then you have metadata optional, and then spec and status fields. Now we will look at the spec field. So yeah, so there are different fields available in the cluster policy spec. So you have apply rules. So this controls how rules are applied in a policy. And then you have background, whether you want it to apply in the background. Then failure policy, as we spoke about. This is interesting: generate existing on policy update. So based on if you're running a generate rule, so this particular field controls whether to trigger generate rule in existing resources. So like the namespace example that I mentioned earlier, whenever there is an incoming new namespace request, you want, say, resource quota to be generated. But what if you're introducing Kyverno in an already existing environment and there are already different namespaces available in your cluster? So if you set this field to true, it will look at the different namespaces that are there and still generate all the resource quota and network policies or whatever that you want for the existing namespaces as well. Similar to generate existing, we have mutate existing. So mutate existing is something like, in the example that I mentioned before, was for any incoming pod request, if the container image spec has the latest tag, you want to mutate that to something else. But that is for an incoming request. So what about the resources that are already there? So if you set this field to true, it is going to mutate all the existing resources as well. And then rules, this is, every policy will have one or more rules. So this is the rules list. Then you have schema validation. So you can choose to skip schema validation, but it is not really preferred. You have to go through schema validation, and by default, it is set to true. And the validation failure action, this is the enforce and audit that we spoke about. And the action overrides, you are allowed to override whatever the top level enforce and audit that you mentioned. And of course, the webhook timeout seconds, you can set a custom value, but it must be between 1 and 30 when the default is 10 seconds. So this is about spec. So, feel free to check out the status field. This was for a cluster policy. You can do kubectl explain on policy as well and see what is the difference. But now we will move on to the match block. Earlier we said match block is pretty powerful. So as you can see, there are a number of fields that are supported in a match block. So you can match on resources, each resources, annotation, kinds, names, and you can do namespaces, you can selectors. Again, selectors can have different exceptions. It has key value pairs, and you can also define subjects. You can say subjects for your user group or service accounts. So there's a lot of flexibility in writing either a match or an exclude rule. And yeah, okay. So here we have a sample policy called the cluster policy YAML, and we will just simply do a small exercise of answering different questions here. So I have to pull this back. Okay. So this is the cluster policy. So what type of policy is this? Is this policy or cluster policy? So as we know, it is defined from the kind value here. So if it's a cluster policy, But if it was a policy, there will be a policy here, and we should also specify which namespace that policy is applicable in. Next, we have how many rules does it contain? So rules is an array. So it is, we have 2 rules here. So what type of Kubernetes resource does each rule target? So let's go through one rule here. So here in this rule, we have match and exclude block. So in match, we have resource kind pod, and we have a selector for label that is app critical. So this is going to select all incoming pods only if they have this particular label key value pair app critical. And also it is going to exclude these cluster rules. Like if you're a cluster admin, it is not going to process the rule for your request. Would the first rule apply to the given resource kind if it carried the label app minor? So now the question is, Now the question is, you have an incoming pod, but it contains the label app minor. But here we are saying the label has to be app and the value for this has to be critical. But for this, if it was something like this, like you didn't specify any value, it means you just want that app label to be present. You don't really care about the value. Then probably it would have matched for app minor. But in this particular case, it requires that your incoming pod has a label called critical. So I would leave the second question to you to, identify what would be the answer to this. If not, we are anyway going to upload all the answers to the GitHub repo, and you can refer to it later. So I think Himanshu has an error. Arjun, do you mind looking at it?
Yeah.
I think it is something related to the Docker environment. Okay. I'm just going to wait for a couple of minutes in case people are working through this. If not, feel free to give me a thumbs up. I will simply continue. This cluster policy, you should be, let me check. Okay, probably we did not mention. You have to switch the branch to KCD VLR. I'm sorry, we did not mention that earlier. So change the branch to KCD VLR and go to module 1. You should be seeing the policy there. Sorry about that. Okay. Yeah, so if you already have an EKS cluster, Himanshu, you can directly go ahead and install Kyverno in that. So you'll have to create a kind cluster only locally. Basically, you need any cluster. You can have an EKS cluster or AKS cluster. Then you can straight away start with installing Kyverno. But if you're on your local machine and you don't have any cluster to work with, only then create a local cluster. Okay, all right, I don't see any more questions, so I will move on. So this is it about, module 1. So this is basic Kyverno installation. I hope everybody was able to go through with this. Okay, next, what do we have? Okay, I have to quickly mention about reports as well. So in one of the future tasks or modules, we will look at what a policy report looks like. But to give you a brief overview, policy report is also a custom resource. So it is being worked upon by the working group policy. And there are again 2 types of CRDs, policy report and cluster policy report. So by now it should be fairly clear that policy report is for namespace resources and cluster policy report is for cluster scoped resources. So the type of report is not related to where the rule is found. So it's basically if you have a namespace wherein a rule is violated, you'll be able to see policy report there. And there are different So this is, like I said, it is from Kubernetes policy working group. So it is not something, that is Kyverno specific. So this is a generic policy report format. And there are different kinds of results. So you have pass, fail, warn, error, and skip. So what Kyverno does is it parses the rule, it processes them, and then it says whether this rule has passed, it has failed, or if there's any error when processing the rule. So accordingly, it writes the policy reports. And these policy reports actually are pretty extensible. They are also custom resources. So you can feed it into any, end target that you want. So towards the end of the workshop, I'll probably show how we do it at Nirmata. We consume these policy reports to show a nice, dashboard or nice graphical views of different policies and rules in the cluster. More about policies. So what if you go and, or accidentally delete the reports? So Kyverno recreates that for you. So entries are created upon admission review. So we saw there are different kinds of reports that Kyverno creates: admission review reports, cluster admission review reports. And what if you remove the policy itself? So it is quite possible that your policy report, gets piled up if you just keep creating a number of policy reports. But at some point, if you say go and remove the policy itself, then there's no point in having a report for it. So your policy report gets deleted. So if you want to apply to already existing resources, you have to set background to true. So this will probably look at a future module in some time. We will look, POL-R is short for policy report. So we can describe what a policy report looks like and examine various fields. Oh, great. I already have an example here. So this is the API version, WG policy K8s V1 Alpha 2. So if you remember from the cluster policy, it was Kyverno V1. So this is clearly from working group policy. This is the name of the kind, that is policy report. It's not cluster policy report, so it is namespaced. So, and in what namespace? It's in the default namespace. So results is the array that contains the report of all the different rules. So, and this is the policy name that is being presented here. And this is the resource. So this was the incoming resource. There was some rule processing that has happened within this policy, and this is that particular resource. And this is the result of the rule processing. So this particular policy and rule has passed for this resource. And this is the rule name and so on. And this is the source, so Kyverno. So here, the rule processing engine was Kyverno. So it's not necessary that it's always Kyverno. So if you go and write a custom, policy engine yourself, you can still reuse this policy report because this is a standard. So you can write logic in your own custom policy engine to do the rule processing, but output the report in this format. So that is where you'd say, who is the source of this particular policy report? And then this is a nice summary of, all the results that are there here, how many passed, failed, and so on. Yes. So we have a short break. I see that there are some questions going on. Can multiple K8s cluster use single setup? That is, each requires its own installation. Kyverno deployed, and we looked at what a cloud policy, what a cluster policy looks like, and we also saw the policy report. So best practices in Kubernetes. So we all know, whenever we bring up a cluster or we start with our first deployment, it is always going to be, we do not care much about the best practices. All we want is, to get that cluster up or get that deployment working. But this is just the start, right? It's only to get you started, only to get you familiarized with, the environment. But as and when you progress or you start from your local environment to a dev environment, to a stage, and then finally to a production environment, following best practices become more and more crucial. And in organizations, these serve as a checklist. So if the pod security standards are not being conformed to, then your applications or your environment doesn't make it to prod at all. So it is very important to not just stop at just getting a cluster up or getting your deployment ready, but also pay attention to what are the best practices in Kubernetes, what are the best practices that is required by your organization. So it's not necessary that if you just checkbox whatever Kubernetes is recommending. So obviously Kubernetes recommends a huge list of practices, but some of the organizations, have even more stricter rules and compliances that you have to follow. So it is always good to understand how, how to reach to that level. So, and in that regard, Kyverno, helps you in writing policies. So Kyverno is at the forefront of policy as code. So even though there are like ton of best practices, you can codify all of them. You can write Kyverno policies for almost all of them. And even in the open source policy library, so there are about 250 plus policies. So we already have policies for pod security standards or even RBAC practices. So it is easy to get started even with best practices with Kyverno. So some of the best practices that Kubernetes recommends, is pod security standards. So there are 3 different profiles: privileged, baseline, and restricted. So the controls become more and more restrictive in this particular order. So privileged is you run everything with, highest privilege. You may even run as root. Baseline it's a smaller set of controls, but restricted is a highly restrictive set of controls. We will look at the restricted profile shortly. And then there is RBAC best practices. So, do not have service accounts lingering around. Do not associate your the most powerful service account with any pod. Then it means your pod can assume that particular service account and maybe run as root, which is scary, right? So there are some RBAC best practices as well. And then if you're having a multi-tenancy shared cluster model, so there are some multi-tenancy best practices. We will look at how namespace as a service can be achieved with Kyverno. And then there's supply chain security best practices. So here you have signing container images. You can sign YAML manifests and, sign your SBOMs and so on. So each, aspect of your Kubernetes environment has a certain set of best practices that are there. So this is just 4 different types that I've listed here. But of course, there are, a lot more. Suppose say you're running an EKS cluster. So obviously the generic Kubernetes guideline cannot, be EKS specific, right? So in that case, EKS publishes a list of, security best practices, and you'll have to adhere to that when you're running in an EKS environment. Similarly to OpenShift or AKS, whichever cloud provider you are using, each of them will have their own set of best practices to follow. And the good part is most of those best practices can be codified via Kyverno. So with this short intro, we'll directly jump to the lab in this case. So if you're following along with me, head over to module 2. So here, like we say, enforcing Kubernetes best practices, it becomes easier with Kyverno. So in this exercise, you'll have to clone 2 repositories. One is Nirmata Kyverno policies. So there also we have a bunch of these best practices and standards as Kyverno policies. And this is also Kyverno's policy set. So feel free to take a look at both of those. So there are different policies involved. The policies themselves are not very different, but at Nirmata's Kyverno policies, we just segregate them differently. And the Kyverno policies is, completely sourced from the community. So pod security standards. So like I mentioned, there are 3 different profiles: privileged, baseline, and restricted. There's a detailed documentation on what each of these profile means and what is the best practices for each of those configurations. So it is a pretty exhaustive list. So feel free to take a look. But in this exercise, we will see, first we will run a particular pod and without applying any policies and see what are the things that it can do, right? So here we have a kind cluster, which we created from the previous lab. We have Kyverno running And we do not have any policies. So cpol is short for cluster policies. So we do not have any policies yet. So now imagine you have the cluster ready. Now you want to do a deployment. So I'm going to copy this first command. So what this is doing is I'm directly using kubectl run command. So it says the name of the pod is root and the image name. So, okay, so it says host PID as true, and container image is Alpine latest, and command is this, and security context privilege true. So this is doing most of the things that you should not be doing, right? Like you should not run privilege true. Then it means you can get root access to the underlying host as well. So let me try to run this. So I am inside the container now. So if I do, who am I? So I am root. So now if someone gets access to this, so what are all the possible things they could do? So I can go to my etc folder. So this is literally what is there on my host, right? So this is not now restricted to your container environment. So you can see this password, you can see different profiles or system configurations and so on. So I basically have access to the underlying host, which is a bad thing. So what do we do now? So I'm going to exit from here. How do we stop this from happening, right? So when we were talking about policies, we spoke about you can either set policies in an enforce mode so that such a pod is never allowed at all. And we want that to happen. And for that, we are going to apply new policies. So what this command is doing, we're using customize. So at this location, you can see all the pod security policies that are there. And I'm going to run them in enforce mode. So these are all the policies that is being applied right now. So let us do a kget cpol. Yes. So all of these policies we just applied in enforce mode. This is also doing a background scan true. And the policy is ready. It means now it is, now let us try to run the same kubectl command again. So this time what we want is, because our policies are already in place, we want this pod to be stopped, and that's what happens, right? So it says this particular pod has resource violations, and there are a bunch of them. So it says disallow capabilities strict is not followed because we have to set this particular field. Disallow host namespaces is not valid. And disallow privilege escalation. We did run privileged as true, and that is not a good thing to do. Require run as non-root should be set to true. So we are failing a bunch of policies, and these are Kubernetes best practices. So now just by applying, I don't know, there are like about 10 policies here, I think. So just by applying this, you can easily secure your cluster from such malicious containers or pods running. Let's also look at the policy report. So if you see here in the Kyverno namespace, so all of these rules that were that failed, and these are the different types in the policy report, right? We say pass, fail, warn, error, and so on. So it gives you a nice report of like different namespaces that are there, and what policy and rule failed. This is about task one. So here we tried to run a pod with privileged access. So without policies in place, we were able to run that. And then we applied pod security policies here. And then finally, when we try to run the same pod again, Kyverno blocks the admission at this point. But in case instead of enforce, I had used audit here, then our pod would have still been allowed, but it would have been recorded in the policy report. This exercise is again using Kyverno to implement PSS. So like I said, we have to clone two repositories here, Nirmata Kyverno policies and Kyverno policies. So feel free to go to either of these repositories. Let me just show it to you here. That's pretty straightforward. So in the Nirmata Kyverno policies, we have a bunch of best practices and multi-tenancy and so on. So not just the Kubernetes standard ones, we have curated policies ourselves, such as the EKS best practices. So EKS has a bunch of guidelines on how you should be securing your cluster. So we have converted most of them to policies. And then, PCI DSS is something like an industry standard if you're, and there's also CIS standards, and there's RBAC best practices that I was talking about. So if we go back to the workshop, so in the RBAC part, you can go to the Kyverno policies RBAC folder and apply all the policies that are there. And then I encourage you to take a look at the policy report as well and see what are the different policies and what they map to, right? So this is disable auto mount of SA token. So you do not want a service account token to be auto mounted on each of the pods that are running. So here we say auto mount service token as false. So similarly, we have other policies as well. And I want to show you the Kyverno set of policies. So if you go to kyverno.io and policies, so there are about 265 plus policies. You can filter this based on policy type, but also a policy category. So we have EKS practices, there's policies for Flux, Istio, Linkerd, and the standard ones like pod security, admission, standards. So there are about 260 policies. So if you're getting started, it's most likely that the use cases that you're interested in is definitely one of these policies. So feel free to go through this as well and start applying policies today. I'm not going to apply all these policies, so this is pretty straightforward. If there are there any questions? No, okay. So yeah, from this module, I think the takeaway is going to be that if you're starting your policy journey today or anytime soon, pod security standards is definitely you should get started with. I mean, with using Kyverno, without using Kyverno, it doesn't matter. But following pod security standards is like a basic recommendation from Kubernetes itself, and you should be following that if not already. Okay. So next, I think we have pod security admission, and Arjun is going to walk you through it.
All right. So we talked about pod security best practices, and then we talked about engine best practices. Hey, can you see my screen, by the way?
Yes.
Yes.
Okay. So we talked about the best practices. We talked about pod security standards, but what do pod security standards essentially do? How are they implemented? So the precursor for pod security standards or pod security admission was something we used to call pod security policies, which were deprecated in 116 and then removed in 125. So the problem with them was they were pretty complex to use. They were very granular, but that level of granularity often led to complexity inside your own cluster. So instead, the community moved to something we now call pod security admission. So these are, so when you have pod security standards, these three: privilege, baseline, and restricted, you can apply them on the namespace level or on the cluster level. So that's what we call as pod security admission. Maybe let's just walk through it. We talked about the restricted pod security standard. Similarly, we have, let's see how we can do this in the pod security admission. So I have this namespace here, which I've tagged with this label. And this label essentially tells Kubernetes that, hey, I want restricted pods to go in only inside this namespace. Other pods, I don't want you to allow it. So let me create this namespace here. And then I'm going to try to admit this pod inside this namespace. So let me first try to put this pod inside my default namespace. So since there are no pod security admission or pod security standard policies running on the default namespace, this would work this pod would go in just fine inside the default namespace. So you see the pod is created. But when I do that for the this namespace, then this pod security standard would not allow it to go in, since this is a very basic policy, very basic pod definition, and we don't specify anything such as we don't want privilege escalation and so forth. So you see, I have a number of errors here, right? Now, how to, this is good, right? So we have a set of 3 standard policies, which when violated won't allow the pod to go in. But how do you granularly control this? We saw that with PSPs, that was the problem, that they were too complex to use. But then how do you tackle that problem, since at some point you are going to need granularity anyway, right? So for example, in the namespace, I may want to look at only some of the pods that come in, such as they can have a specific label which would tell us that, hey, I want these pods to not be checked. They can go in as is. So how do you create those exceptions? So there are 2 approaches you can take to this. So one is with Kyverno, that can we have the pod security standards specifications. You can modify them. You can write your own policies, or you can go from the bottom up, and wherever you have pod security admissions, you can create exceptions for them. I'm not talking about policy exceptions, just rules that would allow that exclusion of certain resources, right? So what I mean by that is, let's say I have this pod policy here, okay, and this is a namespace policy. As you can see, the kind is policy, and I have a namespace definition here.
Arjun, 1 second. Sorry to interrupt. People are asking if you could increase the font size in the terminal.
All right. Yeah, is that better?
Ansil, is that better? Do you see better now?
I think some more would be good.
All right. Okay.
Okay.
Yeah. Thanks. Yeah.
Thanks, Arjun. Please continue.
Yeah. So in the policy, you can see I have a match rule which would look for pods, and then it would when in the validation I have this pod security. So this pod security, essentially, is doing the same thing what PSA does on the default namespace now. And the level I've set to restricted, same as what we did here, right? And the version, this specifies the PSS version that you're using. But I have one more thing here that says exclude control name host namespaces. That means there are, in pod security standards, if you look at, let's see. So you have these specifications, right? And this is the specification I'm talking about. So host namespace specification. Now let's say I just want to exclude this, right? Whenever we have, I want to exclude the check for this one, but everything else I want to check. So in the pod security standard, there's also something else called privileged containers. And we don't want them to go in as part of even the baseline standard defines that you don't let the privileged containers go. Okay. So if I define this policy, and let's see if this policy is ready now. So yeah, by the way, whenever your policy goes in, it would usually it takes just around a second or even less for the policy to be ready. But once it is ready, you can see it to be true here, right? Now I have this policy functional, and I'm going to try to admit this pod, okay, which is a privileged pod. So this pod, you can see we have security context.privilege true set, which is the same condition we are checking for, and we don't want that, right? So this pod is expected to not be able to go in. And that's what happened. So Kyverno reports that, hey, you're violating the pod security standard, and that's why I'm not letting this policy go in. But when I have a similar pod, however, I'm now looking for the host IPC true, which is this one. So I want, as part of the baseline policy itself, we don't want the host namespace or we don't want the host IPC to be set to true. Okay. but this pod you'll see would be able to go in, and that's because I had done this exclusion here, right? We excluded this control. So if I apply this pod now, oops. Okay, right. So it has other restrictions as well. Yeah. So everything aside, this one. Okay, so let's say that I want to exclude all of this. So, hey, Anusha, do you have a standard pod that I can use for compliance, and then just exclude this from?
You want a bad pod?
No, a good pod.
Or just change the image to Alpine latest. You want with all the
Yeah.
no, I don't have that.
Okay, let's see what the words, for example, look like. Okay, so there are, and let me just first dial down this to, so I have the baseline policy.
I think if instead of latest, if you give V1 or V2, I think it will work. Just say that latest images are not allowed.
Yeah, at least some ones should go away.
Yeah.
Not for this. I think in the pod spec,
You
we
mean
did Alpine latest. So don't put latest, at least that, one of the errors might go away.
okay. Okay, so you see this was allowed to go in. And so whenever we do this exclusion, so we don't look for this resource itself. Other stuff we can verify, but this one we let go. So this is one rule that I have excluded out of that pod security check. So this policy, all of this would be applied. Only thing is you don't let the you don't check for this rule, even though it's present, you let it go in. And that's the kind of the idea that was behind PSA, that whenever you need granularity, whenever you need positive filters or you need negative filters on PSS, then those filters can be applied using your policy engines, which are such as Kyverno or OPA. And so that was just the idea behind this. And I'm sorry this for the second task, but yeah, I think we got it right in the end. And the idea being, so whenever you want granular controls, and it need not be so like here you can have with PSS, you define it on the namespace level, right? But with Kyverno, you have the flexibility that just for the label check you could do. So for example, you could be looking at the entire cluster, and you only want to apply those standards to a certain set of pods, such as the ones which have the label purpose is production, right? So only those pods you want to put through those strict checks. Otherwise, all of them, the rest of them can go in as is. All right. For the next one, I'm going to hand over to Anusha. Over to you.
Thanks, Arjun. I'm going to give a minute if somebody wants to ask questions on that. Otherwise, I will continue. All right. So multi-tenancy with Kyverno. So we did touch upon how Kyverno can help with namespace as a service. So this is a very common probably scenario wherein you have a shared cluster model. If you are the platform team and you cater to different development teams, you would have a single cluster, but whenever a particular team requests, they would request for a namespace. So you just create a new namespace in your shared cluster and give it to them. So, but there are, again, definitely best practices that you need to follow. And following best practices means nothing but, adding guardrails to your namespaces. So what are the different things that you can do? You can create resource quotas for the namespace. You can set limit ranges. You can create network policies, just so that, one particular team doesn't use up all the resources, or they don't abuse the set of resources that are given to them and, put other teams at risk. So that is why it is important for you as the DevOps or platform admin that you set up guardrails to all your namespaces. And Kyverno definitely can help with this, and we'll see how. And this also aids in providing self-service to your developers. So whenever we talk to our customers at Nirmata, so we have seen that everybody wants to provide sort of a self-service, right? So nobody wants to go back and forth on tickets. Like, I don't want to raise a service desk ticket saying, hey, I want a namespace. And then I have to wait on you to either approve, you could be on leave or whatever. So my development is now delayed. So usually people don't want to interact so much over on tickets or, wait on each other. So everybody prefers to have a self-service model. So a common workflow example that I can give you here is, you can have a model wherein all your development teams can do a simple thing just as raising a PR. So they can raise a PR, maybe that has a form that says, hey, I want a new namespace. I want to run so-and-so workload, and approximately I might be needing so many resources. Whereas you on the as a platform team admin, you can set those standards. Like, I'm going to provide you with 3 different kinds of environment. I can give you a small environment, medium environment, or a large environment. So a small environment could mean you're going to get fewer resources, like lesser CPU and memory. Whereas a medium or large, you're going to get more CPU and memory, or, with different set of policies and so on. So you as a platform team can set those standards, and your developer can simply raise a PR saying, I want a namespace of small size. So all you have to do is just approve the PR, and you can set up workflows in such a way that once the PR is approved and your namespace gets created, and that's where Kyverno kicks in. It sees that, okay, a new namespace is being created. I have to create all these different resources. But now you have, this small, medium, and large concept. So you can write Kyverno policies in such a way that if a small namespace is requested, create a namespace with smaller set of resources. Or if a medium namespace is created, create slightly, higher CPUs and memory resources. So all of this is possible with Kyverno, and this is how you can introduce self-service models in a multi-tenancy environment. So we will look partly at this workflow today. And before that, so the rule type that is going to help us in writing these policies is the generate rule type. So just a quick recap, Kyverno supports 4 different types of rule types: validate, mutate, generate, and verify images. So generate is going to be heavily used in this particular module. So what we want to do is, it creates new resources on the fly based on different triggers. It could be now create, update, or delete. So when a new namespace is created, you can create all these resources. Or if something is updated, you can still go ahead and create new resources. And not just namespace. So generate in general works for different kinds of custom resources as well. So your resource definition can be defined in the policy, or you can also clone from an existing resource. So if a resource already exists, you can say just clone whatever is already existing. You can sync different resources, and the most common use case is multi-tenancy or namespace as a service. And you can also synchronize secrets across namespaces. So with this clone feature, if you want a single secret to be copied over or synchronized to other namespaces, you can use that as well. And it works on existing items too. So we saw a particular field when we were exploring different fields in a cluster policy. It was generate on existing. So if you set that field to true, so it also generates these different resources for your existing resources as well. This is a simple example. The policy language here itself is slightly outdated. If you look at any latest generate policy, the syntax is going to be slightly different. So here it says add a network policy. So we are matching on the resource kind namespace. It means whenever a new request comes in for a namespace, you have to generate. So this is the keyword that we are going to use, generate. And what are we going to generate? This is the API version kind. We are going to generate or create a network policy here. And this is the data spec. So if you write a network policy in general, you are going to write the data spec for it. Oops, sorry. You're going to write the spec for it. And you are by default denying any ingress or egress in this namespace. Similarly, this is a cluster policy to sync secrets. So here you're saying sync all image pull secret. So whenever a new namespace is created, you're going to generate a secret. And then you're going to say synchronize to true, and you're going to clone. So we use clone when you want to look up the existing secret and you clone to whatever the target namespace is. So in this lab, we are going to do creating of default network policies. Before that, some general generation behaviors. So when the trigger is matched, an update request is created. So when we say trigger is matched, that is when it matches on whatever the match or exclude block that you've given here. We triggered the generation. And obviously, Kyverno must have permissions to create your resource. So if you add a random resource here, but Kyverno does not have permission to create that, this request is going to fail. And then deleting a policy using data will cause target deletion. Deleting a generated resource with synchronized to will cause immediate recreation. So if you have already set synchronize to true, but then you delete the resource that was generated, we will automatically recreate that resource for you. And variables from admission review are essential. So variables, so Kyverno supports a vast set of variables. So you can read the incoming request fields. In this case, the request object's metadata name, and you can use this as a variable placeholder. So this particular variable in double flower brackets is going to be replaced with the actual request metadata name. So you can use variables as well. And then, okay, so that was like a quick overview of what a generate policy looks like. But the main use case that we are going to focus in this lab is how you can achieve namespace as a service. So this is the workflow I was talking about, wherein a developer or a team requests a new namespace, and you as a platform or DevOps team now has to create a new namespace. So if suppose, Kyverno did not exist, or you do not use Kyverno in your organization, one of the other ways to achieve this would be like you create a Jenkins job. So whenever somebody requests a new namespace, you run this job that does the task of creating the new namespace. It also creates different, resource quotas or network policies. And finally, when the job is completed, you will have to notify whoever it is that, hey, now you can go ahead and use this namespace. But instead of all these, coordination activities, you can make the self-service. You can, create Git workflows to trigger certain, actions such as creating namespace. And with a limited set of policies, or within a single policy, maybe you can codify all of these, which you would have done via Jenkins job, for example. And the best part is these are all YAML policies, right? So you can store these YAML policies as Git files, and you can version control these files. So this is the workflow, and we will try to do this workflow today. And the task here is, okay, now that we have some understanding of what namespace as a service is, so we are going to assume the role of platform admin. So, and say one of your developers now has requested a new namespace with certain resource specific details. And now as a platform admin, how are you going to use Kyverno to do this? So the task is simple. Somebody asks for you for a new namespace. You can just do kubectl create namespace ABC and give it to them. But as a good citizen, you need to be able to apply all the best practices to your namespaces, and we are going to do that now. So let's show it here. Yeah, so we have a set of generate policies. Let's look at some of them. So here this says add NS quota. So this is going to add resource quotas. So what this policy does, so it matches on a resource kind namespace and it generates resource quota for us. So here we have different, data spec. We say CPU is 4, memory is 16 gigs, and some limits here. And then we also generate a limit range for this. So this particular rule, there are two rules in this policy. One is to generate resource quota and one is to generate limit ranges. And in the earlier example where I mentioned you want something like small, medium, and large, you can say match any resource kind namespace with label small or medium or large. If it is small, then generate resource quota of this type. If it is medium, maybe you have increased number of cores, you have 32 gigs and so on. If it is large, it's obviously going to be a large environment. So you can define any set of match conditions here and then generate based on that. In this example, we are just going to generate one resource quota resource and a limit range resource. And then we are going to check, we are going to add label. So here we see that this cluster policy matches again on resource kind namespace. Here we are going to mutate because all we are doing is for the created namespace, we are going to just mutate that particular resource and we are going to add this label created by whoever user this is. And then we are going to generate network policy. So you need to be able to add network policies for your newly created namespaces. So again, the match criteria is going to be same, and we are going to generate a new resource. In this case, it is a network policy. So by default, we are going to deny all requests. Yeah, I think that is pretty much it. So let's go ahead. And this is a sample namespace, of course. So all you have to do is first apply these policies, make sure the policies are there, and then you create a new namespace. So once a new namespace is created, all of this are going to happen on the fly for us. So let's start. So this is module 5. Okay. So we have generate policies. So I'm going to apply all the 3 generate policies that we have. So this got created. Yeah, so now we have 3 policies here. Now we are going to create the sample namespace. So this is just the name test and label type is medium, but we saw that our add NS quota does not actually take into account these labels, but it's simply going to generate one resource quota and limit range for us. So let me apply this. So we have S namespace that's created. Now let's look at resource quota. So yes, a default resource quota was created for us. This is the request and this is the limit. Similarly, if I have to check network policy. So yeah, so a default deny network policy got created for us on the fly. So all I did in this exercise was simply apply all the policies that I want. So here, this is just a sample set of, resource quota and network policies. But if there are any other things that you want to do whenever you create a new namespace, just write those policies, store them somewhere and apply all of them. And from then on, it's pretty much autopilot, right? So whenever you create a new namespace, you can be assured that whatever policies you've applied are going to be generated or mutated. So you are securing your namespaces, you are building a more robust multi-tenant environment, and none of your development teams are going to feel that maybe some other team is using up all the resources on your cluster, and you can safeguard your cluster from all of that. So that is pretty much it for the multi-tenancy use case. I'm going to talk for 30 seconds if there's any question. Otherwise, next we'll move on to supply chain security. All right. So supply chain security, I think many of you have heard about supply chain security quite a bit in the recent past. So I think maybe for around a year or more, maybe around a couple of years now, we've been hearing about shift left security, right? Everybody is talking about we need to shift security left. But how do we do that, or what does that mean? So shift security left means usually security was an afterthought. So if something bad happened to your cluster, only then you realize, okay, it was not secure, or maybe I was not following good practices. But until then, the damage is already done. But what you would ideally want is to take care of all these security best practices as early as possible in your development lifecycle, because the later you find a bug and then fix it, the cost of fixing that bug is going to be, exponentially higher. So you want all these, best practices or hardening processes as early as possible in your development lifecycle, starting from your design phase, and then your coding and building, software, your CI/CD pipelines, and then, your CD pipeline wherein you deploy all of this into your environments. So you want security all along the way. And there's another frequently used term called zero trust, right? So what does that mean? So there are different phases in software lifecycle, right? From, you design, you code, you build, and then you deploy. So each of these phases, you should not assume that, okay, I have written the best code possible, so there cannot be any loopholes in this. I'm just going to ship my software. Or if you say, I have signed my container images, so what could go wrong? I'm going to deploy this. Or you can say, maybe I scan my registries every day, so I'm very sure nothing is going to go wrong. I can deploy this software. But that is not true. You have to apply security best practices at each and every stage of your software delivery, and not trust on any single of these phases. So if you're doing some checks at your build stage, you should definitely be doing checks at your deploy stage as well, and not rely on different stages. So basically, you have zero trust on different phases, and you perform the max number of checks, or you try to provide the highest level of security at every phase. So with some of this context, we will cover today is, the image verification feature in Kyverno. So in the different phases that I mentioned, there are different security tools that are there and that are applicable that you should be using. So say in the coding phase, say when you write a piece of code and you raise a PR, so make sure to use proper linting tools that identify some coding best practices. And when you're packaging software, make sure to sign them. And not just that, when you push your images to registries, be sure to scan for vulnerabilities. So nowadays you have tools like Gripe or Trivi that can scan your container images for vulnerabilities. So you should be using those. And like I said, it's not just enough to sign your container images. You should also verify the signatures when you're deploying them. So here we are going to talk about that particular use case wherein you sign an image and then you verify that image signature during deployment. Again, recapping the different rule types in Kyverno, there's validate, mutate, generate, and verify images. And we will look at verify images now. So you can use verify images, that is, you can write rules to check signatures or attestations. So it ensures supply chain security. That images are signed with the expected key or metadata. It also integrates with KMS. It supports annotation verification, and any portion of your attestation you can write rules for. And there are multi-way checks that you can say any of them, all of them, or you can say things like at least one rule should match and so on. This is a typical image verification policy. Again, the syntax is slightly outdated, but I think we should be good for this example. So the validation failure action is enforce. It means if the image signature verification fails, we are not going to allow the deployment to progress. And the failure policies fail. So if the rule can be evaluated or if this webhook itself cannot be reached, we are going to drop the request. Now this matches on incoming kind pod. So whenever you want to deploy a new pod, you are going to verify the signature. So this is the keyword here, verify images. So up until now, we saw validate, mutate, and generate. But here we are seeing verify images. This is the image reference. So you might be running different kinds of images in your environment, but we want to verify for certain images. Again, you can use star here. So you can say GHCR IO star. So any deployment from GHCR, we are going to perform verification. Or you can go a little further ahead and say GHCR IO Kyverno star. So anything in the Kyverno repository is going to get verified. And then attesters, or who or what is providing the signature. So count one. So it's like one person or like one entity is providing the signature or has signed the image. So here it is the public key. So whenever you generate keys, I'm sure you must be aware that you're going to get a public key and a private key pair. So you use the private key to sign the image, but then you use the public key to verify that it was indeed the same, the corresponding private key was used when signing the image. Can we also check the image repository? Prabhu, can you elaborate a little more?
Yeah, Anusha. So can we also check which image repository it's from, like whitelisting the repository?
So you want to say something like from GHCR, I'm pretty sure it's going to work, and don't verify for those?
No.
Yes, definitely.
It should allow only images from GHCR, not from anything else.
Oh, yes. So in that case, you don't actually do verify images. You use the validate key rule type, and you can whitelist there. So you can say image repositories and GHCR star and so on.
Okay.
So here specifically, we are verifying the signature present in the repository. So here we provide the public key, and so we'll see this in action. Yes, I think that would be better. Let me switch to the module here. Yes. So for this task, we'll use Sixtor's cosine. So like I said, the Kyverno is already compatible with cosine. And in the 1.10 release, we also added Docker's Notary V2 support. So I actually have generated this key pair before, so I'll go through the documentation here just to show. So what we'll do is first do a cosine generate key pair. So here it generates a set of private key and public key for you. So so this is where I have created my public key and private key. So once you do that, and any container image that you may have on your local, so what you can do is use cosine sign and sign with the private keys. So when we generate here, you get two keys. One is cosine.key and cosine.pub. .pub is the public key, and we'll use the public key in the policy. This key is the private key, and you should use this for signing your image. So once you sign the image, it is going to also push the signature to your image repository. So the signature is also stored as an OCI artifact. So I'm using Docker for this. So let's look at my Docker Hub account. So I have a bunch of images here. Okay, let's go to the signed one. So here V100 is my actual image, but this is the signature that has been pushed. So once I signed using cosine.sign, it also pushed the signature, with the .sig extension. So this is also stored alongside your image itself. So once you're successful in executing cosine sign, you will also be able to see in your repository the signature as well. So now that we generated the key pair and then we signed the container image, we will see how we can use Kyverno policies to verify whether that image was actually signed. So this is the policy. This is pretty much what I showed on the slide earlier. So it works on pod and deployment. And this time I've changed the image reference to Docker IO Anusha. So here the public key is going to be my public key that is there. I think it is this. Oh, okay. I think I have a different key in the example here. So this is the public key that, whatever .pub was generated along with the generate key pair command. And okay. Coming to module 4. Yeah. Okay. Now I really hope this is the right key. Let's see. Okay. Before we apply this policy, what we are going to do is just run an unsigned image first. So I have an unsigned .v100 here. So let me try to run that. So it says, I'm doing a dry run, by the way. So it's going to say, yes, pod created. Now, what does this mean? I had not signed this image and I'm able to run this. So I might as well run any image from the internet. I don't have guardrails in place that can stop any unsigned images from running. And by the way, if you're executing this alongside me, you might get some error when running this. That's also because I have only these 3 policies right now, but from the first exercise, if you still have all the pod security standards or PSA running, it might be possible that these pods also violate some of those PSS practices and might give you different errors. So just for the sake of it, you can either create a new cluster or just delete those existing policies so that we can concentrate on the only image verification policy here. Okay. So I was able to run an unsigned image. I still haven't applied my image verification policy. So let's go ahead and apply this. So yes, this policy is created. Let's take a look. So yes, my check image is up. Now let's try to run unsigned again. So hopefully this should get blocked. Oh, it created. My policy is wrong somewhere then.
I think it has to be enforced. It is audit mode.
Oh, is it?
Yeah.
Oh, wow. Thank you. Okay, let's see. I applied the policy again, just for that. Okay, now it's in enforce. Now let's run the unsigned one. Yes, thanks for that. So now we see that, admission webhook has denied the request and our check image rule has failed. It has failed to verify this particular image. It says no matching signatures. In our policy, we said that whatever the image is being deployed has to be signed with a private key, which is a pair of this particular public key. And that's not found, and Kyverno is going to stop the deployment. So this in some way adds some additional guardrails to your environment wherein you're not allowing any unsigned images from running. And yeah, so we did this, we ran this. But okay, we did block an unsigned image, but we should also verify that, and actually the signed image that we have over here in our Docker Hub account, if this was indeed the private key, the matching private key, at least this should be allowed. So we are just going to verify that. Yes. So we see that the signed pod is actually allowed, whereas the unsigned pod is not allowed. But we can try to do another small experiment here. Here it was quite straightforward, right? Like an unsigned pod was blocked, but a signed pod was allowed. But now what if I have another signed container image, but this time using a different private key and not the one that is matching to this public key? So we would want even those images to be blocked, because it is not that hard to, with this just do these steps, you can generate any key pair and you can sign your container images. So it is really not hard to sign your images, but it's very important to verify at the time of deployment. So I think I'd leave this exercise to y'all. So if you create another set of key pair and then sign, say, another image with a different key while still using the same policy, you should get an error saying that, this is not a matching key or some key not found or something like that. Basically, Kyverno should block that kind of deployment as well. So that is a exercise I'd leave for you all to try. Yeah, I think that's basically it about supply chain security. Yes. Are there any questions? Otherwise, we have another short break coming up.
Yeah, I have one question. Actually, I know this public and private key thing, but here when we mean sign, what we actually mean, are we encrypting the image with the private key and then decrypting at when the policy engine, checks it, or it's like some JWT token that is there, just verifies that is how it actually works internally.
The actual signature, probably you'll have to go through, how cosign does it when it signs any particular image or artifact, because this is just one way to create public key and private key. There is keyless signing as well. There are different ways. This is generating keys. Okay, there's signing. The local key pair and there's a keyless signing. But the question that you asked on, whether it's going to encrypt or create a JOT token sort of a thing, at least I am not quite sure on that. You'll have to go through the 6stores documentation on how they do it. But on Kyverno side, what it does is it fetches. So at the end, whatever encryption or whatever it is doing, it pushes this signature as an OCI artifact here. So what Kyverno does is it pulls this particular OCI artifact and does the matching for us. So with the signature, you can say whether it was really the private key and the public key pair, right? So Kyverno does that verification for us.
Okay.
This I can try to get the exact information, but I'm sure it would be somewhere buried in this document. The next module is going to be on policy exceptions. This is a new feature that was introduced in 1.9, and Arjun will take us through it.
So far we have been talking about policies, right? All of them have been policies. They're doing validation, mutation, generation. We have talked about verify images as well. But there are places where you need exceptions, right? And that you can do with the exclude block that we had in policies. We saw that, right? And but there are times when you can't modify that policy. For example, let's say you have a Git repository, and every time you have to go through a long approval process, or even if that's not the case, you have an immutable policy on your cluster. So in that case, when we can't change policies, but we also need exceptions to those, how can we do that? So Kyverno 1.9 added policy exceptions, which is capable of doing this for you. It's a CRD, same as we have policies, we have policy reports. This is also a CRD. So let me show you the fields first. So there are, just as the match and exclude field we have for policies, we have for these as well. And the schema is same, everything is same here. We just have one more block, that's the exceptions. So in the exceptions, you define the rule name and the policy to which it would apply. So let me pull up an example first, and you can see. So this is a policy exception. You have the match block here, and then the exception. So in the exceptions, you define the policy name and the rule names. Policies have rules, and those rules are named. So I've just listed them here from this policy, and this is my policy name. All right. Also, these policy exceptions are namespaced resources. They are not cluster wide. They are stored in a namespace. Usually, it's this namespace is the one that you define in this Kyverno container argument. It's by default set to Kyverno. You can define policy exceptions outside this namespace as well, but it would not work. I mean, it would throw a warning, although it would work. So to see policy exceptions in action, first let's look at this flowchart. So you have a start, and then once you have, let's say, a validation policy, which is set to enforce mode. With audit, you don't need really a policy exception because anyway the resource is going in. So let's say you have an enforce mode policy, and the user and Kyverno detects the violation, right? So the next thing it would do is it would check if a policy exception for that rule that is being violated is present. And if that is the case, then the resource isn't allowed to go in. Otherwise, we block that resource. Another thing is that is not visible here, but when you see policy name here, and the policy I'm talking about here is a cluster policy, but you can also create policy exception for namespace policies. You just have to prefix it with the namespace here. So just like any resource you do, the schema would be something like namespace and slash policy name. So let's go through this exercise. But before we can work with policy exceptions, something to note is right now it's an alpha feature, so it's behind the feature flag. This flag needs to be added to the Kyverno container. Let me edit this deployment. So in the Kyverno namespace, I have these resources, and I want to update this deployment. So these are the arguments, and this is the namespace I was mentioning. By default, all your policy exceptions would ideally be in this namespace. And this is, I'm just setting this enable policy exception feature flag to true. And I wait for the pod to restart. Okay, so Kyverno is up and running now. Now I'm going to, let's look at this task first. So what I'm trying to do here is, I have this policy, disallow latest tab. So it would not allow the resources to go in, which are, not allow the pods to go in, which have image tags set to latest, or which do not have a latest, or do not have an image tag, right? So one example could be this one, right? Image, if this is your image. So this pod would not be allowed to be admitted if we are looking at this policy. So let's try it out. Okay. So the validation failure action mode is set to enforce. Now I'm going to try to admit this pod. So since it violates the policy, I'm not able to admit this pod. Another thing is in this policy exception that we are going to use, you see it works on this namespace that we defined. Right? When in the match rule, we are looking for this namespace. And what this policy exception is ideally supposed to do is all the policies, all the pods would be checked for by this cluster policy. But if that pod has a label type equals to dev, in that case, if it's a development pod, then I don't want, I want that this pod should be accepted from that, right? If that is the case, if it's a development pod, then the development pod can be running with latest, because I usually with the development, you'll build it from your main branch, and then it would be tagged with latest and published. So those images should be allowed in, right? So, yeah. Let's try to define this policy exception now. And before that, I'll also create this namespace, since it's not the, and yeah, you see the policy exception in the policy namespace, the policy exception namespace in which we are defining is the same as the one in the container argument, right? So I have this policy exception created now, and this I can check. So this is not in the default namespace, it's in the Kyverno namespace. Polix is just shorthand for the policy exception. And see, this policy exception is created now. Now, if I try to admit the same pod, right, in the test namespace. So let's create the namespace first. Just a second, folks. Okay. So I have the test namespace created, and I'm trying to admit the admit a production type pod. Okay, it's labeled with type equals to prod. So this ideally it would not be allowed to go in as expected, right? Because in the policy exception, I was matching for this label, right? So let's try to admit a pod which is running with this label, right? But this pod is allowed to go in because that's what the policy exception was supposed to do, except all pods that that are running with this label. And that's just how simple using policy exceptions is. So idea being, it's more although you can include your exceptions or exclusions inside the policy itself, but it is more extensible if you treat it as a separate object. Let's see. Okay, any questions on policy exceptions? Okay, no questions. Then we have the last module. That's our cleanup policies. We can jump to that. All right. Okay. So cleanup policies, as the name suggests, is Kyverno can clean up your cluster. So there are times, let's say you have jobs that have completed and you may want to pick them up. Or let's say you have outdated pods that you don't need anymore. So periodically you can run checks using these policies to pick up those resources. So again, cleanup policies are just like your cluster policy or your namespace policy. They are also of two types. They can either be cluster scoped or they can be namespace scoped. And same how we do for policies. If it's a cluster cleanup policy, then it's a cluster-wide resource. If it's a cleanup policy, then it's a namespace resource. So in the cleanup policies, again, let's do a case explain here. So, okay, let's look at the spec. We have these four fields: conditions, exclude, match, schedule. Again, schedule, exclude and match is the recurring pattern that we have seen. And then we have conditions and schedule. So schedule is your cron format in which the controller would check for this cleanup policy. And conditions are whatever resources, which resources you are going to select and the conditions on them. Right? And this is an optional one because you already have match and exclude, right? So this is more like there's also a construct called preconditions. So preconditions, let me show you how that looks. I don't know if we have covered that yet. So, so preconditions can have these checks, right? Like you can have a key which you can select, and then you check its value using an operator. Right? And then these keys can be pretty complex. You can have James path functions, which we unfortunately did not have the time to cover, but they are a very cool feature of Kyverno. You can do arithmetic operations. You can extract timestamps, process them, process strings. A lot of James path functions are natively supported. So let's look at the cleanup policies. Okay. So also one more thing, the cleanup policies are can run on any resource. That means essentially Kyverno would need to have the permission to clean up any resource or delete any resource. And that's obviously very sensitive permission to give. So Kyverno, since it follows the principle of least privilege, it would not allow, it would expect the user to grant those permissions manually whenever they need it, right? And we have the aggregate cluster roles that we can use, but I'm going to just edit the existing roles for ease. Let me show you. And we can also meanwhile go through whatever roles Kyverno is using right now, right? So this is the cleanup controller. The cleanup controller, by the way, is a separate component. So you can see that Kyverno pod is running, and then along with that is a cleanup controller pod. This pod is specifically just not dealing with mutation or validation or generation, verify images. All it does is cleans up, right? So you can see it has the standard permissions for the webhooks, which we need to handle because we are running a controller. Same for namespaces and so forth. Cron jobs, because it is creating jobs, it is cleaning up using jobs internally. And events, because it has to generate cleanup events. So I'm going to, for this task 1, I'm going to clean up pods. So I need to add appropriate permissions for them. So I'm going to copy this and paste this inside the existing cluster role. So when I do that, okay, let me remove this first and show you what happens if I don't have this permission. So let's try to define this cluster policy. If I try to admit this cluster policy, I would get this error since the cleanup controller does not have that permission to delete the pod. Right? Now I'm going to edit that same cluster role with this. And now let's see if I'm going to create 2 pods. One is going to have this label and the other one won't. So because we are matching only for this pod, whichever has the can remove label set to true, only those pods would be cleaned up. The others won't be, right? So let me define this. Let's watch these pods. By the way, in the cron expression, we have 1 minute schedule. So this would run per 1 minute. And as I said, this one conditions. Conditions block is optional, so we did not use it here. But if you have a more complex cleanup policy, you can obviously use that. Any questions so far? Also, you can take a look at the cleanup policies like that. I should look for cluster cleanup policies. Ooh. Oh, right. Sorry about that. I did not apply the cleanup policy after I edited the row. That's why it doesn't show up here. Let's see if there are other examples. This is also this is also an alpha feature right now. Going forward, we are going to GA this. So So after this cleanup policy was run, the first pod Nginx one was picked up and deleted because I have the label set to true, but the second pod was not because I have not specified that label. Okay. For a more complex example, so I'm just trying to club cleanup policies with policy exceptions. So we see how Kyverno can also work with CRDs and not just Kyverno's and Kubernetes-native resources. So I'm going to create a policy exception and I'm going to try to clean it up with a cluster cleanup policy. Okay, it's the same policy exception, by the way, that we used earlier. And same for what we did for pod. We are going to do that, and we are going to add that policy exception to the cluster. And now in this, all we had to do was change the kind from pods to policy exceptions, right? More like it should be policy exception, not there's a typo here. Okay, let's take a look at the policy exceptions we have. This one is in the default namespace, and I'm going to clean it out with this policy. And all the rules that you have for match, exclude, all those work with your custom resources, just as they do with Kubernetes resources. Yeah, so see, now the policy exception was cleaned out. And that's about it from the modules perspective. Next, I'll hand over to Anusha.
Thanks, Arjun. So yeah, I know we are at 5:35, so I'll quickly try to wrap up with this last bit. I just want to talk a little bit about the Nirmata Policy Manager. So until now, we saw everything about, Kyverno, how you can write policies, how you can look at policy reports. So what does Nirmata provide additionally, right? So it is for multi-cluster management for Kyverno and, for all your cloud providers. So this policy manager is cloud provider agnostic, and it can manage clusters at scale. And we have curated policy sets. We'll also help you write your own policies based on your requirements. You can have a complete view of the different policy reports, and especially when you have multiple clusters running, you would want to know what is going on in what cluster. You'll also get different metrics. Okay. You can get different metrics. You can get different events that are generated in your clusters. There's finer, access control. So you can define teams and users. You can just assign different roles for each of these teams. We also have integration with tools like Slack, Jira. So if you can configure them in such a way that if there's any violation, send a notification to Slack or create a Jira ticket. There are different alarms that you can set for different types of policy violation. You can set alarms like if an exception is created or if some image verification failed and so on. And obviously we have compliance standards. So we provide the industry standards such as NIST, CIS, and PCI DSS. But apart from that, we also have Nirmata set of standards like multi-tenancy, and the RBAC that we saw in today's exercise was from the Nirmata standards. This is a quick, this is a screenshot of what our policy manager looks like. And this is the dashboard view. Here you can see I've onboarded 3 clusters. You can onboard as many as you want. And onboarding is also completely, automated. So Helm charts are available. You can do it in your CI/CD via CLI as well. And also there's a friendly UI also present. You can get a quick summary of how many policies and rules that are running, what is the status of each of them. And this is the compliance related information. Then you can view violations by different categories, by different cloud providers. So here I have only AWS, but you can literally have any cloud provider or on-prem cluster, or even the local kind cluster that you created today can be onboarded onto the Nirmata Policy Manager. We also have image scan feature. So we can scan your images for vulnerabilities, and you can also write policies such as, if there are image vulnerabilities of CV, severity, medium or above, don't deploy those pods. So it's possible to write Kyverno policies for scan reports as well. Then you can see violations by clusters, by different namespaces that you want, and so on. So there are a bunch of features available in the Nirmata Policy Manager. And this is if you're a little bit mature in your policy journey. But if you're just starting out with policy and governance, we also provide enterprise support for Kyverno. We will help you on board with Kyverno and also, train you and your teams on what are the best practices of writing policies and managing Kyverno itself. Because like we saw, Kyverno sits in the critical path of admission control. So it is very critical that you manage Kyverno properly. You handle upgrades properly because Kyverno is still in incubating phase. So new features keep churning up with every release. So your upgrades, we can ensure that they are smooth and all your policies are up and running. So with that, I think to summarize, like we went through like what, why policy is needed, to how dynamic admission control works in Kubernetes, to what are just webhooks, to Kyverno architecture, and when we went through several different use cases. But that is just tip of the iceberg that we touched upon today. So there are a lot of other things that that are there in Kyverno, and the 110 is bringing up more features. So I'd urge you all to like go look at the documentation. There are so many blogs available, and we covered the most common use cases today. But there are like few articles that mention about a variety of different use cases, how you can use cleanup policies and policy exception to create useful workflows for your organization and so on. And yeah, so these are different resources that are there. Probably I'll add a couple of articles that talk mainly about the most recent features and how you can play with it. And if you want to get in touch with us, we are always there on Kubernetes Slack, but feel free to ping us on any of the social accounts. Or I think you can also email to support@nirmata.com. So this is the, I think, final Q&A, and we will take in any questions, but thank you for attending. So this was a Saturday afternoon, and this was a pretty long workshop, to be honest. So thank you. If there are any questions.